Hello, we'd just like to do an introduction regarding a very interesting company called Anello who'd like to talk to us about what happens when there isn't the world of GPS.
Hi, my name is Mario. I'm with Anello Photonics. And what we've created is technology that allows you to operate autonomous in applications with no GPS. And it's all based on this, what we call SiPhOG, Silicon Photonics optical gyro. So we've taken the concept of high precision fiber gyros, which have been around for 30 years, big, bulky, coffee can size, and we've shrunk it based on integrated silicon photonics, which is using the same processing as integrated circuits. We take that, we add a laser, we put some very complicated electronics, and this is the world's smallest fiber optic gyro on a chip.
Right.
Put it in your hand?
Yep.
This is it, right?
So if you're a potential customer of yours, you probably would have had the perception that this kind of technology wasn't for you because it's flying around in
fighter jets,
ICBMs,
high-end places that can afford big, expensive things.
Yes.
Submarines.
Yes.
Right?
So this world wasn't for you. So you've changed the world in terms of where gyroscopes can go and the value that they can bring to the world.
We've changed it by bringing capability that can be high volume manufacturable, size, weight, area, power, and apply that capability to new applications that people never thought you could do. So now construction, farming, agriculture, automobiles, robots, everyone wants high precision.
Right.
But you can't afford it in these applications.
No. But the benefit to that is that you would have seen that where we started talking about GPS. Those applications are very reliant on GPS signal, for instance, in a drone. So explain to us in an application like with a drone, where your technology comes into its own.
Sure. So this is the SiPhOG, and we take this core technology and we build systems, inertial navigation systems. So that puts in a CPU, AI algorithms, GPS capability.
So there's a lot in there.
That's just the SiPhOG, but then we build systems. So this is a land vehicle system, which we call a GNSS INS for land vehicles. But this is what we announced this week at CES. This is the world's first 3-axis. So if you take this, all right, I'm going to open it up. You hold that piece.
Yep.
I hold this piece, and now you count 1, 2, 3. There's 3 SiPhOGs in here, and you put it all together. Put that back here. This now, you got to turn it. It only fits one way. This now fits in the palm of your hand. This is a high precision optical gyro that's less than half a pound, less than 4 watts. Still high precision.
Which would never have existed before.
Never existed. But now what can you do with this?
Yeah.
Now you can put this in things that are dependent on like drones, right? You can't put a $50,000 box on a drone, right? That's 12 watts or 20 watts.
Yeah.
So we can take this now, and if you go over here, we actually have a drone, and we have some videos here, but we now apply this to a drone. And what's the big thing with drones? They're aerial. Today, if you're flying an autopilot on a drone and it loses GPS, guess what happens?
You're going to tell me, but it either falls out of the sky or it stays where it is.
It stays and hovers, and eventually either runs out of power or crashes because it doesn't know where to go. It doesn't, right? And so we've developed this capability where now we can put this into drones and aerial things, and you need that motion. But more importantly, we've developed an algorithm, and we modified the autopilot to say, hey, lost GPS. Are you sure you've lost GPS? Yes. Oh, we have Anello X3. Don't worry. Continue to fly. And we can fly through jammed or contested regions. We're talking about doing 10 kilometers of flight, no GPS, with less than 100-meter error. And why is that important?
And what is the reality of GPS falling out over that period of time?
Well, what happens, and unfortunately today, if you take what's happening around the world with adversaries, they're doing a lot of jamming and spoofing.
Right.
And so there's certain areas that are being jammed. These drones aren't getting shot down, they're just being jammed. And so you have to be able to fly through those jammed regions, and then you pick up GPS again, you can realign, and you can continue to do that. The other thing is, because this is optical, it can't be jammed or spoofed. It's not electrical, right? The photons don't interact.
No.
So this system cannot be electrically jammed. And so you can know when it's being jammed, but you say, hey, rely on Anello because it's dependent on itself. And so we've come up with, I think it's a radical change. Today, there is no solution for operating in GPS denied, cost effectively, low power, and a small form factor. And we've developed a technology today that's not anti-jamming, that's not anti-trying to revert, with a low-cost Silicon Photonics based SiPhOG. Then now we have the IMU, the Anello X3, which we just launched, and the interest level for this is off the charts.
Yeah. So then tell us a little bit about the other product that you got there.
Okay, so we think about this, I call it land, air, and sea, or maritime. So 3-axis, when you're flying, you need 3 axes, right? If you go 2 feet underwater, 3 feet underwater, what happens to the GPS signal?
It goes again.
Does it? So now we can do the same thing, and we can do maritime, either above water and below. What do we have to do? It's the same technology, but we have to modify the algorithms, because the way the motion and the algorithms tell you how you navigate through, constantly looking at signals. We have accelerometers in here. We have MEMS sensors for course alignment. So we have a multiple of technology in here that centrifuge together to combine to build an overall solution. Now, let's take a land vehicle. If I'm operating in land, well, at least today there's no flying cars. It's coming. I saw a bunch at the show. I don't know if you've seen them, but one of these days we'll get in a flying car, right? Everyone's talking about it. But until that happens, cars ride on the land, and if you look at that, 95% of the performance is based on the heading or your direction. So we've created this GNSS INS product, which we launched this summer, that has one optical gyro technology, and we call it the Z-axis or the heading. Combine that with GPS antennas, we have a CPU and AI algorithm, and now this is a very simple, you can plug it in. A lot of the tests we do, we just strap it on the dashboard. We have an algorithm that corrects for the alignment, and now you can drive your vehicle with no GPS. In a very cost-effective, simple manner, set this up, plug it into your cigarette lighter, plug it in, and in 15 minutes you have a high-end autonomous system that's very affordable.
Yeah, so again, with this kind of vehicle, where would GPS, where would you have a problem with GPS?
So let's give you examples. What we can do with this, right? There's sort of 2 cases. There's a short term and long term. Short term, let's talk about agriculture, farming, mining. You go into a tunnel, there's no GPS. Agriculture, you're up and down the orchards. The leaves in the fall block the GPS signal. So as if you want to do an autonomous agriculture, you go up and down the roads. These are like a mile long, and you turn and go down, but you want to stay within a couple feet so you don't hit the trees.
Yeah.
Right?
Very confined areas.
Very confined. So we've optimized the algorithms for that use case, but here we're doing sub-centimeter accuracy up and down an orchard. So now you can plug this in. This is hardened, salt spray, sealed unit to work outside, and now you can retrofit any vehicle, and now you can have it autonomously operating in an agricultural environment.
Right.
And we have some agriculture design.
So you can retrofit that?
Yes, you can attach this, and remember the output of this can be just applied to your steering or whatever. It's just the standard. We've optimized this so it's all standard protocols. So we have some design wins in agriculture, which we can't announce yet. Hopefully later this year we'll announce. But that's land vehicle, short term. Let's think about long term. And there's some applications in defense where they want to go hours, and they just want to know where their fleet of vehicles are. So we've gone 50, 60 kilometers an hour driving in roads with no GPS with this unit, and guess what kind of accuracy? So you can imagine we're going 50 kilometers, 60 kilometers, 60 miles an hour for an hour. I'm missing kilometers and miles here. And we have less than 100-meter error.
Really?
No GPS. It's unheard of. It's like 0.1% distance traveled. So now we have, again, the same capability that I can do short distance and long distance. But again, we say here, we're completely changing the way we operate or navigate and autonomously with GPS-denied environments.
Yeah. So, I mean, in summary, many people out there are trying to solve problems, understanding where their vehicles are, be they a drone, be they in agriculture, be they in mining, be they part of a fleet, and they would have perceived that the only solution to that was GPS, and that gyroscope would have been out.
It was too expensive. Why would I?
Just not have been an option to them.
Yes.
And what you're saying now is you can absolutely think of an alternative to GPS using gyroscope technology.
And a lot of it is customer says, customers even stopping by here. I didn't know you could do that. I didn't know it existed. oh, we have one of those fiber gyros. They sit in the closet because there's no way you're going to use that in production. And so we're basically brought high-end fiber gyro capability, integrated it with Silicon Photonics, and now created with SiPhOG, we're going to take high precision optical gyro capability to the mass market.
Yeah, so that's the future.
That's the future.
So if for instance we're looking at something that's this size today, then this.
And then if you think about Moore's Law over the last 50,
Absolutely.
60 years, and I had the pleasure to, I know Gordon is a friend and has unfortunately passed away, but we're going to do the same thing at Anello. We're going to take integrated photonics, integrated electronics. What you see today, we're going to outdo ourselves. In the future, we're going to go smaller, lower power, and continue to apply. As you go smaller and lower power and lower cost, what happens? New markets open up.
Yeah.
Eventually, maybe this gets into the consumer market because we'll have a tiny chip that's integrated, same performance, but now you can put this everywhere.
Yeah. So I mean, the key thing there is what you're introducing is the whole concept of an alternative, safe, reliable alternative to GPS. But don't think that it's just today. You're going to be able to make that smaller, more
Absolutely.
efficient, more cost-effective as each iteration moves forward.
Anello, as the time goes on, you'll be hearing more and more about Anello. So again, today we launched the X3. Contact us at anellophotonics.com. Get on the list. The wait list is quite long already on this, but this is a leapfrog in performance for aerial mapping, drone surveying. We also have existing products for robots, land vehicles. Come visit us on our website. We'll get you some evaluation. We'll test. More importantly, tell us what your applications are and let us figure out how we can apply Anello technology to solve your autonomous problems.
Don't think GPS, think Anello.
You know what Anello means, by the way?
No.
All right. So Anello means ring in Italian.
Does it?
So again, this is an optical. See the little all these
Yeah.
chips. So Anello means ring in Italian. That's where the name comes from.
Very good.
So it's
Very
a
good.
fiber gyro ring.